Look at this question. We've got in this particular picture a circle. We've got a sector of a circle which you can see being mapped out. Radius is r, we don't know r. You're told the angle subtended by the sector at the centre is pi by 6. I've used the little notation there for radians, a little c. Normally you wouldn't see that, it would just be written as pi by 6 because remember radians are just a number. But sometimes you might see that little c there, so I'll do that for this example. You're told at the side some information. The area shaded in the picture, which is, well, that line there is actually a chord, and so this here that's shaded is actually a segment of the circle. It's the minor segment created by that chord, and you're told that the area of this minor segment shaded is 15 square centimetres. Now, based on that information, the question is basically saying calculate the radius r in centimetres. So this is what we're going to do. First of all, I'm going to set up the logic that we'd use to work out the area shaded. The area shaded of the segment, this segment here, will be equal to, how would you work it out if you were going to try and work that out from scratch? Well, from this sort of information, you'd say that you take, let me highlight this, the area of the sector, first of all, the whole sector. So we take the area of the sector, and then if I now change colour to show you what I mean, I'll go to red. What we're going to do now is then work out the area of the triangle, this triangle here. I'll go over this in red, this triangle. So this triangle here, which I'll faintly shade in. And what we're going to do is subtract that triangle away from the sector. And so you have the whole sector, and you subtract that triangle away from it, and that will leave you the shaded area of the segment we want. So it's the sector take away the triangle that I need to work out. Now in this particular case, the area shaded is a figure that we actually know. We're not actually asked to work it out. We know it's 15. So I can on the left change that to 15 equals the sector area, the whole sector area, is a formula a half r squared theta. Take away, and then the area of a triangle, I'll use the formula you should be familiar with from year 11 when you did the cosine rule, for example. It's a half AB sine C. We now substitute in things that we know for these things on the right hand side. So on the left you've got 15, and on the right hand side we've got equals a half. Now the radius r squared, we don't know what the radius is, we need to calculate r, so I'll leave r as r squared, and theta is the angle subtended at the centre, pi by 6, which we do know. So you get that, subtract a half. Now A, B and C are the three letters which correspond to the notation for the triangle. Now at the moment there are no letters labelling the triangle, so what I'm going to do is suggest to you we do this. Sine of C, well, C is the angle subtended in this corner here of that triangle, so it would make sense for me to call that C, and therefore I can call the other two A and B, like so. And if I label the triangle with those three letters, corner A, corner B, corner C, then opposite corner B or angle B of the triangle over here will be little b side length. Opposite big A, angle big A there for the triangle over there would be little a, and likewise opposite big C would be little c side length. That's the notation if you're using this formula. So let's sub in little a. Little a is this distance from there to there. Well, that's from the centre to the outside. That is, as well as that, the same as the radius. So that's the radius and that's the radius. So I know that A and B are both the radius. So little a is replaced with r, little b is replaced with another r, and then we've got sine of the angle big C, and sine of pi by 6 is that in radians. So we get to there. So let's just tidy up. You end up with 15 on the left is equal to, this simplifies to pi r squared over 12. 2 times 6 is 12. Take away. Now for this one we've got sine of pi by 6, which you should know, or you can look at it on a calculator in radian mode if you want to. It's the same as sine of 30 degrees, which you should know is a half, but you can look it up like I said. So it's a half, or 0.5. A half times another half is a quarter, so this is going to be simply r squared over 4. So we get that. I'd probably here say let's times everything through by 12 to get rid of the fractions, although you don't need to do this if you don't want to. So if I times everything through by 12, times that by 12, what you're going to get 180, I think, on the left. Times that by 12, you get pi r squared. Take away and times that by 12. Well, the 12 and the 4 would cancel to give you 3 r squared. So we get to there. Now this is an equation in r squared. It's a quadratic equation for r. Now what I could do if I wanted to, I could change that at this stage to 3.14 and then work out 3.14 r squared, take away 3r squared, and do it in that fashion if you want to. Or, this is what I'm going to do, you could do this, 180 equals, take out r squared as a common factor, leaving you with pi minus 3, like so, inside the bracket. Divide both sides by the bracket, so you get 180 over pi minus 3 equals r squared. And then finally square root both sides, so you get the square root of 180 over pi minus 3 equals r. And that basically is an expression for the radius in centimetres. In some questions at A level, they may ask you to find r, but more than that, they may say prove that r is, and then tell you that as the answer that you've got to prove. So they might say prove that r is square root of 180 over pi minus 3 centimetres, in which case you need to do it in that fashion. Other times they might just say find r to 2 decimal places. Well, if that's the case, what you'd have to do is work out what this is to 2dp. So if I just quickly, I've got a calculator at the side here, I'll just work out what 180, I'll do it approximately, divided by, well, 3.14 take away 3 is 0.14. Okay, and if we do that, we get an answer, and then I've got to square root that, so I'm going to square root this answer now, and we get an answer of 35.86 centimetres for the radius to 2 decimal places. Okay, and that's the end of this video.